Hello viewers, welcome to the 6th lecture of this course on mathematical finance, which is going to be the 3rd lecture of module 2. So, in this lecture we will essentially look at yield curves and term structure of interest rates in details and illustrate this with a few examples. So, let us begin this lecture with what is known as the price yield curve. So, what is the motivation of the price yield curve? The motivation of the price yield curve is to ascertain essentially the return that you expect to get for various yields in case of both a pure discount bond as well as a coupon bond. So, formally we will define a price yield curve as follows. So, a price yield curve is a graph, a two-dimensional graph, where we plot the price of the bond on the y axis against the yield of the bond. So, consider prices as percentage of the par value with specified maturity. So, a price yield curve typically will look something like this. So, on the x axis we will consider the prices as percentage of par value, and on the x axis we will look at the yield maturity. So, this is essentially what we are going to do is the price yield curve for 30-year bonds with several coupon rates. So, we will look at several cases where we have different coupon rates, and we will just see how the price changes depending on what is the yield to maturity. So, first let us look at a graph when the coupon is 0%. So, in this case at initial time point the price is basically going to be 100%. Then suppose we have the coupons at 5%, then this is going to be the graph of 5%. Likewise, we have the graph for 10% and say 15%. We will now make a couple of observations from the graph that we have just seen. So, the first observation that we make is that the bond prices will go down. So, that means as the yield increases, as we move from left to right on the x axis, the curve keeps going down. So, the interpretation of this is that the bond price will go down if the rates or the yields go up. And the second observation that we make is that bonds with higher coupon rates cost more. So, this means that if you go back to the graph, let us look at let us try to see how this interpretation is to be looked at in a meaningful way. So, if you look carefully in the graphs, the first observation that I said is the bond prices will go down if the rates or the yields go up. So, that means that if we are moving from left to right of the x axis, that is the yields are going up, then the bond prices are going down. Then if you start looking at all the graphs in a comparative manner, you observe that as the coupon rates are increasing, that means that in this case say I have 10%, 0%, when I go to 5%, then corresponding to the same yield to maturity, I will have a higher bond price. Likewise, if you go up to 10%, then for every yield to maturity, the price of the bond is going to be higher than in case where the coupons are 0% and 5%, and this trend continues. So, what this means is that as the yields or the rates go down, the bond prices will go up, and in case the yield or the rate goes up, then obviously the bond prices are going to go down. And in the second case, it is intuitively sort of obvious that as you are moving along these graphs and as the coupon rates go up, the prices of the bonds are going to go higher. And the reason for this is that as compared to say for example, a 0% bond or a bond with 0% coupon, when you invest in a bond with 5% coupon, then the payments that you receive from the person or the entity which has issued the bond, the payments are going to be collectively a larger sum, and hence it is obvious that at the initial time point you would have made a larger investment in terms of the price of the bond as compared to when you are looking at a bond where the coupon rates are smaller, in which case you are obviously going to get a lesser amount of money until maturity. Now, this motivates us to talk about something known as the term structure of interest rates. So, the next topic we look at is the term structure of interest rates, and this brings us to the observation that it is essential to look at the rates for all maturities as they progress over time. So, this brings us to what is known as the yield curve. So, yield curve essentially will give you a relationship between the maturity and the rates. As so, a yield curve is a graph or a curve where we plot the yields of various bonds against maturity values, and by maturity values you mean the actual maturity. And typically the shape of this graph or the curve varies on two things, or varies according to two things, namely varies over time, and secondly varies from country to country. So, for the first observation, what you can say that when I said it varies over time, that means for different maturities you will have different rates that are applicable. And my second observation, that it varies from country to country. This means that the interest rate that is prevailing for a certain period of time or certain maturity will keep changing as you look at bonds for various different countries. So, then we look at the following observation, that typically yields for longer maturities, that means long term bonds, are higher than the yields for short term maturities, or rather for shorter maturities. This means that if you are, for example, purchasing a bond say for a period of 6 months, then typically you will observe that the interest rate that you are getting or the yield that you are getting on that bond of 6 months is going to be lower than what you would typically get for a longer duration or maturity of say 5 years. But having said so, what I have said just now is a typical situation. However, it is possible that once in a while this particular trend of relationship between the yield and the maturity may not hold in a similar fashion, and this for this I mean that sometimes a short term bond may yield more than a long term bond. So, graphically if we observe this, this is going to look something like this. So, if I have this as years to maturity, that means the remaining duration of the bond, maybe 10 years, 20 years, 30 years and so on, and the yield in terms of percentage, say this is 1, 2, 3, 4, 5, 6 and so on. So, typically the graph will look like this, but occasionally the graph might dip, that is to say that for a longer duration you might actually get a lesser yield as compared to a shorter duration, but typically you will have this graph always going up. So, next I start looking at what is known as the spot rates, and this is a very important concept in interest rate modeling. So, the spot rate is defined as follows: the annualized nominal interest rate, remember I am talking about the annualized nominal interest rate of a pure discount bond is called the spot rate. Now, for the pure discount bonds, the spot rate is equal to its yield. So, it is obvious that the spot rate is going to be equal to yield in case of a pure discount bond, because you are making an initial payment which is the price of the bond and you receive a final payment. So, whatever is the prevailing interest rate that is applicable for this particular bond is obviously going to match the yield of the bond. So, next we illustrate this through an example. So, in this example we consider a pure discount bond that will mature in 6 months. So, this is basically a 6-month 0 coupon bond. Now, what are the characteristics in this case? It has the price of 98 and the nominal value of 100. So, this means that today at time t equal to 0, the price of the bond is 98 and at the end of 6 months you receive an amount of 100, which is your nominal value. Then the annualized compound rate which I will denote as R6M for this example is obtained as follows. So, 98 is going to be the final value 100 divided by 1 plus R6M, which is the annualized interest rate, raised to half, because this interest rate is applicable for the maturity of this bond, namely 6 months. So, if you solve this, this will have the solution of R6M is equal to 0.41233, which is 4.1233%. So, in this case we say this formally that the 6-month spot rate is 4.1233%. So, in this case we have used the 6-month compounding convention. However, we have used basically the compounded interest formula in order to ascertain this percentage. However, in practice what happens is that, in practice the simple rate convention is typically used. So, accordingly, in this example the implicit rate of return is calculated as follows. So, what do you do in this case? You will essentially in order to ascertain the rate using the simple interest convention, which is typically what is done, we will take the initial price of the bond and we will look at the nominal value and we will just calculate the interest rate that is applicable for 6 months and then use the simple interest rate convention to convert it into an annualized rate. So, accordingly we will calculate this as follows, that 98 is equal to 100 divided by 1 plus R, which gives you R to be equal to 0.20408, or this is 2.0408% or approximately 2.041%. Now, from the formula it is obvious that this is the interest rate that is applicable for 6 months. Now, if you are going to convert this into an annualized rate using the simple interest convention, then you simply multiply the interest rate of 6 months by a factor of 2, so that it gives you an equivalent annual interest rate. So, that means, so therefore, the 6-month annualized spot rate is quoted as 2 times 2.0408%, which is equal to 4.0816%. We now look at another example where we will look at a case where the maturity is more than 1 year, that is it is a long duration bond. So, now we consider a bond with 2-year maturity, and as previously this bond being considered is going to be a pure discount bond, and the characteristics of this are that the price of the bond is 91 and the nominal of the bond is 100. Then the 2-year spot rate, which will denote as R subscript 2y, is obtained as follows. That means, I take the amount 91, which is the price of the bond. This is equal to 100 divided by 1 plus R 2y square, and I am using continuous compounding convention, and this gives you R 2y is equal to 0.48285 or 4.8285%. So, basically this is going to be the 2-year interest rate making use of the continuous compounding convention. However, making use of the simple interest convention, we have this alternative result. So, alternatively 91 is going to be equal to 100 divided by 1 plus R, which is the implicit rate, and if we solve this, R is going to be equal to 0.98901 or 9.8901%. The interest rate R that you are considering, this is the interest rate that is prevalent for 2 years, or rather applicable for 2 years, and then we have to turn it into an annualized rate making use of the simple interest convention. So, that can be simply done, that since this is a 2-year rate, so therefore, the simple interest rate driven annual rate is going to be equal to 9.8901%, which is applicable for 2 years. So, for 1 year the interest rate will be this multiplied by 0.5, which is 4.9451%. Now, the relationship between the yields of bonds for various maturities is of practical importance to investors and practitioners. Now, since this is of great interest, that means that we need to have a sort of a one point or one stop representation of all these rates. And why is this of great interest? A simple example in our day to day life is that when you are going to a bank to purchase a fixed deposit, what is presented to us is basically the interest rates for various maturities, and then looking at that we decide on whatever interest rate is of relevance to us, and typically a rational investor would choose the maturity of the bond that they are going to buy to be the one that offers the highest interest rate. So, even at a retail investor level, it is critical that they know what is going to be essentially the term structure of the interest rate or what is going to be the yields against the maturity. So, accordingly, so this collection of the spot rates for all maturities that are available is called as the term structure of interest rates. And typically when you talk about term structures, so typically when we talk of term structure, it refers to the term structure of government bonds. So, now that we have spoken about term structures, let us now look at an example on how to derive a term structure. So, this example will be on deriving points on the term structure. So, suppose today's date is 1st January 2018 and we want to determine as many points as possible in today's term structure of interest rates. So, the question that you want to answer here is that how do we ascertain the term structure for various maturities, and we want to essentially get as many maturities as possible, so that we can actually graph as many as possible corresponding interest rate that is applicable for those maturities. So, suppose that now this is basically then going to be decided on the basis of the available bonds in the market. So, in this example, suppose we consider that there are 3 bonds in the market, and so accordingly we will be able to ascertain 3 points on the term structure. So, let me begin by specifying the characteristics and the nominal price etc. for each of those 3 bonds, and see how we can make use of the concept of the interest rates that we have studied so far in order to determine a term structure with 3 points corresponding to those 3 maturities. So, therefore, let us look at these 3 bonds. I will call them as bond 1, bond 2 and bond 3. So, there are 3 bonds, 3 risk free bonds with specifications as given. So, I have bond 1, bond 2 and bond 3. So, first let me state the characteristics of the first bond, which I call as bond 1. So, bond 1 is a pure discount bond, and this is maturing on 30th June 2018. So, remember I had taken today's date as 1st January 2018 and it is maturing, the first bond, bond 1 is maturing on 30th June 2018. So, that means that this is a 6 month pure discount bond. And thirdly, the bond is currently selling, or the price of the bond today, which is 1st January 2018, is 98. Okay. Now, let us look at a second bond or bond 2. This is going to be a coupon bond. Now, since we talk about coupon bond, we need to specify what are going to be the coupons that are going to be paid and at what duration. So, this coupon bond pays 6% of its nominal as coupons annually, and this maturity is on 30th June 2019. So, remember today's date was 1st January 2018 and this bond is maturing on 30th June 2019, which means that the maturity of the bond is going to be 1.5 years or 18 months. So, now here I have to specify one thing. I have said that it pays 6% of its nominals as coupons annually. So, what I mean here is the following, that the question might naturally arise that when I am talking about coupons being paid annually, this might seem to be somewhat contradictory that this bond is only has a remaining duration of 18 months, but one can view this as a bond that has already been issued at a prior time point, and that these coupons annually are going to be coupons that are going to be paid on 30th June of every year. So, this means that here the coupons are paid on 30th June 2018 and 30th June 2019, and the bond is selling today at a price, the price of the bond is 101. Finally, we come to the third bond, which we designated as bond 3. So, this is also a coupon bond and it pays 8% of its nominal as coupons annually, and the maturity is on 30th June 2020. So, if it is an annual coupons bond, this means that the coupons are paid on 30th June 2018, 30th June 2019 and 30th June 2020, and the price of the bond is 105. So, there is one last missing piece of information that you have not included, and since we are talking about coupons and pure discount bonds, we need to have a nominal value. So, the nominal value for all the 3 bonds is 100, or the face value is 100. Okay. So, with this piece of information, what is the question that we want to answer? The question that we want to answer is that what is going to be the construction of the term structure. So, let us take the first bond and go one by one. So, we first compute the 6-month interest rate, and how do we do it? Remember, the nominal value or the face value is 100 and the price of the 6-month bond is 98. So, that means, if R is the interest rate, then R becomes 2.041%. So, this is exactly the same example that we have already done, the first example that we had seen in today's class. So, what this will mean is that if you use the simple interest rate convention, then the annual rate R 6m is going to be 2 into 2.041%, which is 4.082%. So, this is one number we would like to actually note down. For the first bond, this is going to be the interest rate, annual interest rate that is going to prevail. Now, next we look at the second bond. So, what are the characteristics of the second bond? The second bond is of maturity 18 months. And what are the payments that you are going to receive? The payments that you are going to receive are that at the end of 6 months, you receive a coupon of 6% calculated on the face value of 100. So, that means the coupon payment is going to be equal to 6, and at the end of 18 months, you are going to receive again a coupon of 6 plus the nominal value or the face value of 100, that is 106. So, then the interest rate R is calculated as remember what is the price? The price was 101. This is equal to the present value of the first coupon and the present value of the second coupon added up. Now, for the first coupon, we have already calculated, the first coupon was paid after 6 months, and we have already calculated the interest rate for the first 6 months in case of bond 1, and we are going to utilize that number. And so, this is going to be 6 divided by 1 plus 0.2041. So, we have basically taken this value from here, because this is already decided as the 6-month interest rate. And now, we have to ascertain the 18-month interest rate, because 106 is the amount that you will receive 18 months after you have purchased the bond. So, this will become 1 plus R. Solving this, you get R is equal to 11.438%. So, you make use of the simple interest rate convention, okay. And so, we basically then get the annual rate is going to be equal to, remember 11.438% that we have figured out here, that is the interest rate that is going to be applicable for 18 months. So, accordingly, the annual rate can be obtained by scaling it down to 12 months or 1 year. So, accordingly 11.438%, this has to be multiplied by a factor of 2/3, which I got by taking. So, basically this is going to be a factor of 12/18, which is 2/3, and therefore, this annual rate turns out to be equal to 7.625%. So, this is another key number. So, I basically found out the second interest rate in the term structure, which is applicable in case of 18 months. Now, let me come back to the third bond. So, in case of the third bond, bond 3, what are the characteristics? So, remember that in case of bond 3, the nominal face value is again 100 and the coupons that are being paid, those coupons are of an amount of 8 and 8 at the end of 6 and 18 months, and at the final time point, that is at the end of 2.5 years, you end up getting 8 plus 100. So, that means at 6 months you basically get an amount of 8, at 18 months you get an amount of 8, and at the end of 30 months you get an amount of 8 plus 100, which is 108. So, now remember what is the price of this bond? The price of this bond was 100, and this is going to be the present value of the amount of 8 that you receive at the end of 6 months plus the present value of amount of 8 that you receive at the end of 18 months and the present value of the amount of 108 that you receive at the end of 30 months or 2.5 years. Now, for 8, since the coupon of 8 is being paid at the end of 6 months, so in order to calculate the present value, we will make use of the interest rate that we had determined for the bond with 6 months, because this can essentially be treated as a 6-month pure discount bond, and this is going to be 1 plus 0.0241. Now, next, in order to calculate the present value of the coupon payment of 8 that is actually being made at the end of 18 months, we will make use of the interest rate for 18 months that we have determined here, that is 11.438%. So, accordingly we will divide this or discount this by a factor of 1 plus 0.11438, and finally 108 will be discounted at the interest rate prevailing for 30 months, which is what we are going to determine in case of the third bond. So, this will be divided by 1 plus r. So, if you make use of this, you end up getting r is equal to 20.025%. So, this again you make use of simple interest convention, and this is going to give you. Now, this 20.025%, what does this interest rate signify? This is basically the interest rate that is applicable for a period of 2.5 years or 30 months. So, that means 5/2 years. So, that means when you have to convert this to an interest rate that is applicable for a period of 1 year, then we multiply this by a factor of 2/5. So, therefore, under the simple interest convention, the annual rate is R 30 M is equal to R into 2/5, and this is going to be 8.010%. So, to sum up, we just present all the interest rate, because we have started off with the problem of the setting up the term structure by making use of the information or the characteristics of the 3 bond. So, to summarize this, what have we got? We have got that in case of 6 months, the annual interest rate that is prevalent is 4.082%. All right. So, you go back, remember we had this number. Then in case of 18 months, the interest rate is 7.625%. Remember, this is the annualized rate that we had got in case of the bond of 18 months. And finally, we have the rate of 8.010% that was determined for the coupon bond lasting 30 months. So, for 30 months we have 8.010%. And if you observe carefully, as my maturity of the bond increases from 6 months to 18 months, the corresponding annual rate goes up from 4.082% to 7.62%, and further as I go from 18 months to 30 months, the corresponding interest rate goes up from 7.625% to 8.010%. Remember that these interest rates are interest rates determined for the bonds that are applicable at an annual level. So, these are the annualized interest rate, and based on this one little example, we see that this example shows us that this is consistent, or the observations of this example are consistent with an earlier statement made that typically depending on the maturity, the interest rates you can expect them to typically go up. That is, the bonds with the lesser maturity or shorter maturity will have lower interest rates as compared to bonds with longer maturity. So, this completes our second module, which was essentially focused on interest rates. So, in the third module, we will start discussing more in details about the basic principles of financial derivatives in general. Thank you for watching.